All right, let me share my screen. All right, so last week we had been looking at histograms, and we had done a histogram on the TI-84 calculator. And histograms on the TI-84, they do a very good job. But I had promised you that we were going to look at Excel also. So, stupid computer. I am going to do that this morning. I am going to put the data that we had in our calculator in Excel and show you that it's pretty easy to do a histogram. So I'm going to use get some things open here. Okay, so I went to Stat and then Edit, and my list is in the first couple of lists here. So let me arrow over. It looks like I put more data in there. So let's just put this data in here. I don't know how much is in here. I don't want to put a lot of it. That's quite a bit, but we'll go ahead and do it anyway. Okay, so what I'm going to do is I'm going to put this data just like it is in Excel, and I'm going to put it in two columns. So we have the L1 list. I'm going to put that in column 1. And maybe I won't put all of this data in here just to save time. Now the problem with Excel is when they use some algorithm to decide the number of bins or the number of bars that they use, and it doesn't always agree with what you want to use. And you can change the number of bins, but even that doesn't work very well. So what I do is I create a bar chart and then I fudge it using Excel. So what else do we have? We have 65.9, let's do 66, and let's do 67, and maybe 68 and 69. Okay, so now in the next column, I'm going to put the frequency. So the frequency is the number of times that that data value occurs. Okay, so now that I have my data in Excel, I'm going to insert a chart. Get my mouse over here. Okay, so what I'm going to do is I'm going to select those two columns of data. So I'm going to click in the upper left-hand corner, and I'm going to click and just hold down, and I'm going to select all that data. See if I can do that. There we go. Oop. Try this again. There we go. All right, so now that I have the data selected, I'm going to go up here at the top in my menu in Excel, and I'm going to select Insert. And now I have charts, all sorts of charts that I can insert. And I'm just going to click on what Excel is currently recommending. So I'm going to choose that. And you can see that it recommends several different kinds of charts, including a scatter plot. The one below that is the columns chart, and that's what I'm going to use. Now you could go up here. Do you see up here in the menu, I have recommended and all. So if I click on all, I can go down there and find the histogram. And when I look at the histogram, oops, that's a box plot. You don't want that. My mouse is not working very well. You can see that the histogram, I mean, that's just strange looking. So I'm not going to use that. I'm not going to use the histogram. I'm going to go back up and I'm going to select my recommended. Well, I give up. My mouse is not working. And I'm going to select a column chart. Okay, so it creates what looks to be kind of a histogram-y to me, except a histogram, all the bars are contiguous. They don't overlap, but they do touch each other. And you can tell Excel to decrease the spacing between each of these bars to 0, and it will create a histogram for you. So if I click on one of the bars, it's going to open the Format Series menu, and I can change the gap width, which is here, 219%. I can change that to 0. And when I do that, it changes the bars, so now that they touch each other and it looks like a histogram. So again, what I did was I inputted the data in 2 columns. Then I selected those 2 columns and I did an insert and I did a column chart. And then I just select any one of the columns, any of the bars, and double click on it. So give it a good double click. That opens the Format Data Series dialog box, the menu, and I can change the gap width to 0. So now you have a histogram. So if you were doing this and you're doing your homework and you needed to pick the correct histogram out of the list, that's what your histogram would look like. Okay, so it's pretty easy to do in Excel. It's also easy to do on your calculator, but you may have to change the width of your bar. So again, how did we do that? We took the maximum in our case is what, 69. So we would go a half above 69. So the greatest value would be 69.5. And our smallest was what? 59. So we're going to go 58.5. We take the difference in those and divide it by the number of bars we want. And your calculator will then create the histogram using that number of bars. So, 6 of one, half dozen of the other. Excel works pretty well, as does your calculator. Calculator works very well. Okay, all right. All right, so once you create a histogram, either in Excel or using your calculator, the data that you graph using a histogram, the shape of it can tell you some things. And the first thing we kind of look at for the shape of our histogram is skewness. So for this particular histogram, it's for the data values 4, 5, 6, 6, 6, 7, 7, 7, 7, and 8. You can see that you have less data values over on the left. So your greatest number of occurrences of your data are occurring to the right. So you've got this kind of tail to the left. So we call that skewed to the left because the data is being pulled to the left by those lower values. So if you have more values to the right and less values to the left, that's skewed left. So the opposite would be true for skewed right. You're going to have the kind of tail to the right and more values to the left. So that is skewed right. So this is the histogram for the data values 6, 7, 7, 7, 7, 8, 8, 8, 9, and 10. So that would, since we have more data toward the lower end or to the left, and we have a tail to the right, this is called skewed right. So one of the first things that our histogram can tell us is if our data is skewed. Of course, if you didn't have this tail, if you had that nice pretty bell shape, which we looked at last week for our soccer players' heights, it was soccer players. We had that kind of nice pretty shape that you could imagine be bell shaped. That's symmetric, or you can have data that's skewed one way or the other. Okay, a frequency polygon are analogous to line graphs. So you can do these in Excel, except a frequency polygon starts at a Y value of 0 or a horizontal, that's vertical, isn't it? A vertical value of 0 and ends at a vertical value of 0. So that's the only difference between a frequency polygon and a line graph. So to construct a frequency polygon, you first organize the data as if you were graphing a histogram. Then you mark the midpoints of the intervals on the x-axis. So you take your classes and you add the lower limit and the upper limit and you divide by 2. That gives you the midpoint of each class. Now you plot the midpoint and the frequency as an ordered pair on your graph. So the first coordinate in your ordered pair is your midpoint. Your second coordinate in your ordered pair is the frequency of that class. Then you connect the dots. Now what you do, however, as you can see in this frequency polygon, here are our lower bound and our upper bound. So these are our class limits. So to find the midpoint of that first class, you take 49.5, you add 59.5, and you divide that by 2. So the midpoint of that first category, that first class, is 54.5. And the frequency of that class is 5. So you're going to plot the point 54.5, 5, which is this point right here. But you notice there is a point that's on the horizontal axis, 44.5, 0. So a frequency polygon starts on the horizontal axis at 0. So if we were to find a midpoint of a class below the class from 49.5 to 59.5, there would be a class 44.5, and the frequency of that class would be 0. So you're going to plot that point. So every frequency polygon starts on the horizontal axis and it ends on the horizontal axis. So our last class here goes from 89.5 to 99.5. So its midpoint would be what, 94.5? And its frequency is 15.
I have a question. Where are you getting the 94 from?
I'm adding, good question. To get the 94, you take the lower bound plus the upper bound and you divide it by 2. And that gives you the midpoint of that class.
Okay, thank you.
Good question. So 94.5, the frequency is 15. So the point that we would plot on the horizontal axis is 94.5, 15, which is this point right here. But in this frequency polygon, we must end on the horizontal axis. So what we do is the next class above this that contains no items its midpoint would be 10 more, or 104.5, which is this point right here. So frequency polygons have to begin on the horizontal axis at 0 and on the vertical axis at 0. So you can draw this in Excel if you wanted to by just, again, creating 2 columns of data. The first column of data would be all the midpoints of your classes, and the second column would be the frequency. So you would start at 44.5, 0, and you would end at 104.5, 0. So your frequency for those 2 points would be 0. And then you just tell it to draw a line graph. It doesn't do a great job, but it does the job. Okay? So that's a frequency polygon. It just matches the midpoint of each class to its frequency. Gives you an ordered pair that you can plot on your graph. The first horizontal value of your ordered pair is the midpoint of your class. The second number is your frequency. So you go over on the horizontal axis to wherever your midpoint is and up to your whatever your frequency is. Okay, the last type of graph we look at is a time series graph. This simply means that the horizontal axis is time. To construct a time series graph, we must look at both pieces of our paired data. We start with a standard Cartesian coordinate plane. Nobody calls it the Cartesian coordinate plane anymore. It's the coordinate plane. The coordinate plane simply means you've got a vertical and a horizontal axis. That's all it means. And you can plot points on this horizontal and vertical plane by ordered pairs, where the first value tells you where you go horizontally and the second value tells you where you go vertically. The horizontal axis is used to plot the date or time increments. So horizontal is going to be time, and the vertical axis is used to plot the values of the variable that we are measuring. By doing this, we can make each point on the graph correspond to a date and a measured quantity. The points on the graph are typically connected by straight lines in the order in which they occur. And gosh, one that you've probably seen, a time series graph that you've seen a lot in the past 20 years or so, past 30 years. I know you're not 30 years old, but those of you who are old enough to remember in the early 90s, when global warming became a thing that we were interested in and concerned about, there are a lot of time series graphs out there that shows you temperature versus time. So the horizontal axis is time, the vertical axis is temperature, or gosh, in the middle of COVID. COVID graphs are everywhere. Now that my husband has COVID, the horizontal axis is time and the vertical axis is how many COVID cases are reported. So we see those all the time too. So here is an example, speaking of global warming, you can see the horizontal axis is time. It is years starting in the year 2003 and going to the year 2009. And the vertical axis is the United States CO2, carbon dioxide emissions. So in 2003, we had 5.7 million parts per, whatever that is, parts per million in carbon dioxide emissions. So we can actually plot that. In 2003 on the vertical, we could plot 5.68 and we can see what happens. And the nice thing about time series graphs is that you can see a trend as time goes by. You can see the trend of, in this case, CO2 emissions or COVID cases. And if you get enough time, you can see general trends of what's happening over time. All right. All right, the next thing we're going to look at in section 2.3 is measures of the location of data. We're going to look at quartiles and we're going to look at percentiles. To calculate quartiles and percentiles, the data must first be ordered from smallest to largest. You have to rank your data from the smallest value to the largest value. Quartiles are the values that break your data into 4 equal parts. It breaks your data into quarters. Percentiles divide your data into hundredths. For example, we talked about this last week. If you score in the 90th percentile of an exam, that doesn't mean you made 90%. That doesn't mean that you got 90% of the questions correct. What that means is that you score 90% of the test scores are the same or less than your score, or you scored above or equal to 90% of the other people who took the exam, or 10% of the test scores are the same or greater than your test score. So it just shows you where you rank in terms of all the other people who took the test. And this is a frequent way that we describe standardized tests, that you scored in the 90th percentile or the 95th percentile or whatever. The median is the center of your data. So it is the data value that breaks your data into 2 equal parts. It doesn't necessarily have to be the observed, one of your observed data values, or one of the ones that you've actually collected, one of the data values you've collected, but it is the number that separates your data into 2 halves. So half your data is below the median and half your data is above the median. And the median is the same thing as the second quartile. It's the same thing as the 50th percentile. So the median, the second quartile, and the 50th percentile are all the same number. It's the number that splits your data into 2 equal halves. Okay, we need to define something called the interquartile range, and we'll define what the quartiles are in just a second. But when we talk about quartiles, and I got missing subscripts here, let's just fix that. This should be a subscript. And I have the power to fix that. All right, that looks better. So the interquartile range is a number that indicates the spread of the middle half or the middle 50% of your data. It's the difference in the third quartile and the first quartile. Now, if the second quartile is the median, or the number that splits your data into halves, the first quartile is the number that splits the first half of your data into halves. Or it's the first quarter of your data is below that number and 3/4 of your data is above it. The third quartile is the number that splits the second half of your data in half. So 75% of your data is below, 3/4 is below, 1/4 is above. So the interquartile range is just the difference in the third quartile and the first quartile. And we use that interquartile range to determine if you have data values that are outliers. So what we do is we take that interquartile range, whatever that number is, we multiply it by 1.5. So it can be considered an outlier when it tells me my internet connection is unstable, I pause. So if you see me pause, that's the reason I'm doing that. I'm on my home Wi-Fi. Even if I'm on the school's Wi-Fi, it tells me occasionally that my internet connection is unstable, and it can mess with the audio in the video. Okay, anyway, so if we take that interquartile range and we multiply it by 1.5, if we are below the first quartile by that amount, so we take the first quartile and subtract 1.5 times the interquartile range, if we're below that number, then that's probably an outlier. If we take our third quartile and we add this 1.5 times the interquartile range, that is kind of the limit of our outliers on the upper end. So if we have a number that's beyond the third quartile by 1.5 times the interquartile range, that's probably an outlier. Okay. All right, so here are our formulas for finding the kth percentile or the kth quartile. So to calculate quartiles and percentiles, the data must be ordered from smallest to largest. Oh, we've already read all this stuff anyway. So the formula is, so for a percentile, to find the kth percentile, the data value position I, so that's where it's located in your data, can be found by taking K, which is the percentile that you're interested in, dividing it by 100 and multiplying that by n plus 1. N is the number of data values that you have. So it's the number, the size of your sample, if you will. So I tells you what data value that is. And we'll do an example here in a second. If you're looking for quartiles, now I think quartiles are very easy to find just by looking at your data. However, if you've got 300 data values, once you've ranked it, finding the quartiles can be maybe complicated by just looking at it, but your calculator will find quartiles for you, by the way. Okay, so to find the quartiles, the value, the number, the location of your data value I, so what data value it is, can be found by K, which is the number of quartiles you're looking for. So K is 1 if you're looking for the first quartile. It's 2 if you're looking for the second. It's 3 if you're looking for the third. So you take that number, divide it by 4, and you multiply it by n times 1. Again, n being the number of data values you have, your sample size. So for example, here are 29 ages for Academy Award-winning Best Actors in order from the smallest to the largest. And I think I've Googled this before, who was 18 when they won the Academy Award for Best Actor and who was 77. Now I can't remember, but anyway. So find the 70th percentile. So find the data value for which 70% of the data value lies below that and the 30% lies above that. And then find the 83rd percentile. So to find the 70th percentile, what we're going to do is we're going to replace K, since that's the percentile we're interested in, with 70. So we're interested in finding the 70th percentile. I have 29 data values, so n is 29, and I just calculate the math. So what it tells me, I'm not sure why people are calling me. I am in a meeting. Just a second, let me tell my son that I'm in class. My children think I don't work. Anyway, so where were we? So what it tells us is that the 21, or the data value that occurs in the 21st position of our 29 data values, is the 70th percentile. So if I start at 18, If I start that 18 is the first data value, then I just count over to the 21st data value. And the 21st data value is 64. So 64 is the 70th percentile. Now to find the 83rd percentile, we replace K in our formula with 83 in the number of data values we have. Our sample size is 29. And we carry out the arithmetic, 83 over 100 times 29 plus 1. And we find 24.9. Now that's not an integer, so we just round it up to 25. So the data value that's in the 25th place in our ranked data is the 83rd percentile. So if I just count starting at 1 is 18, count over to 25 data values, I see that 71 is the 83rd percentile. Let's see what they're saying. Yeah. He's being a good son. He's checking to see if I'm okay. All right, to find the quartiles, you use the same formula. K is now going to be whatever quartile you're trying to find. So, for example, if we want to find the first and the third quartile, which we need the first and the third quartile to look for the interquartile range and determine if we have any outliers. So if we look at these 13 real estate prices, this is of some homes, I don't know, 13 homes, in the area that I live in. I live out in the country, but I live less than 3 miles from Bob Funk. And if you're familiar with the Yukon area, Bob Funk is the guy that owns Express Employment Services. So he is a multi-millionaire. And 2.5 miles, 3 miles down the road here, he has a 21,000 square foot mansion. So if we just look at a 5-mile radius of where I live, the home values can go anywhere from across the road here, the home values less than $100,000 to whatever Bob Funk's house is worth, which is probably in the millions. So you can see that home prices is one of those things where you can get a vast range of values. So here are 13 real estate prices. So let's calculate the first quartile and the third quartile. So again, K is the quartile that you're interested in. So if I'm going to calculate the first quartile, I want K to be 1. The formula, we're going to use 1 over 4. We multiply that by the number of data values that we have, which is 13 plus 1. So we get 3.5. So what we do with the quartiles, since it's 3.5, the first quartile is going to be between the third and the fourth data value. So the third data value in the ranked data is right here. That's the third. And the fourth is right here. So to find the first quartile, we take the average of those two data values. So we take the average of the third and the fourth, since it's halfway in between. So we take the 230,500 plus the 387,000. We add those together and we divide it by 2. So we find the average of those two numbers. To find the third quartile, I do the same thing. I replace the K with 3, carry out the arithmetic, and I get 10.5. So the third quartile is between the 10th and the 11th value. So I count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I take the average of the 10th and the 11th value, which is 649,000. So my first quartile is 308,750, and my third quartile is 649,000. Now, for a small data set like this, you can just look at it and determine what the quartiles are. The median is the middle data value. So since I have 13 data values, the median is going to be the data value smack dab in the middle. So it would be the 7th data value. So 1, 2, 3, 4, 5, 6. So there's the median. 1, 2, 3, 4, 5, 6. There are 6 data values above and 6 data values below. So to find the first quartile, we look at the lower half of the data, so the data to the left of the median, and we find the data value that's in the middle. Since I have 6 data values below the median, then the first quartile is going to be the average of the middle 2 data values. If I look at the third quartile, I look at the second half of my data. So I look at the 6 data values that are above my median, and it's going to be the average of the middle 2 values. So what do I have? My middle 2 values are right here. So I find the average of those 2 values. So the first quartile is the data value that splits the first half of my data in half. And the third quartile is the data value that splits the second half of my data in half. All right. So one way we can use this is to determine if we have outliers. So we determined that the first quartile was 308,750. And the second quartile was 649,000. So the interquartile range is the difference. So we take the first quartile and subtract it from the third. Now, if your data is ranked, obviously your third quartile is going to be a larger number, or it can be the same number, larger number than your first quartile. So we take the difference. So our interquartile range, which is hard for me to say, is the difference between Q3 and Q1, which is 340,250. Now I take that number, the 340,250, and I multiply that by 1.5. And I get 510,375. So I take that 510,375 and I subtract that from the first quartile. And I get negative 201,625. Then I take that 1.5 times the interquartile range and I add it to the third quartile. And I get 1,159,375. So if I have a data value that is beyond negative 201,625, which I don't, these are real estate values. If you have a value that's negative 200 and something thousand, you got a problem. But if I have a data value that was below that number, rule of thumb says it's an outlier, or based on this rule, it's an outlier. Or if I have a home price, a real estate price that's above the 1,159,375, that's potentially an outlier also. And as you can see, I have a $5.5 million real estate value. So that is possibly an outlier. It doesn't fit the typical real estate value range that I'm in this area. So as you can see, you know, where I live 2.5 miles from Bob Funk's 21,000 square foot mansion, he would probably be considered an outlier in real estate values. I also live a half a mile from a pretty swanky neighborhood. All the houses are on an acre of land, and they're all big fancy houses. So my little dinky house out here on the farm is not worth near as much as their house on a half an acre or an acre, whatever's on. All right. Now, what if you want to know, given you have a data value, you want to know what percentile that is. And that's probably the more typical way that you would use this. As an example, when we talked about taking a standardized test, and you know that the person knows the score on that standardized test, and they can tell you what percentile that score is. So here's the formula for finding what percentile you are. You take X plus a half of Y and divide that by N, and then multiply that by 100. So X is the data value counting from the smallest to that, whatever that number is. So if you're interested what the percentile is of, I don't know, 69.5, you count where 69.5 is in your ranked data. And Y is the number of data values you have equal to that value. So if I had 10 69s and a half, Y would be 10. If I have 1 69 and a half, Y would be 1. And N is the total number of data values that you have. Okay, so it's your sample size or the population size, whatever you're talking about. So it's the number of pieces of data that you have. So X is the data value you're interested in. Where is it located? What data value is that? Y is the number of times that particular data value occurs. And N is the total number of data values you have. So here is our 29 Academy Award winners for Best Actor, ranked data from the smallest is 18 to the largest is 77. So find the percentile for 58. So what percentile is the age 58? So the first thing you do is you count what data value is that. So you start at the lowest one and you just count over to 58. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it is the 19th data value. So X is going to be 19. Now you want to determine how many times the 58 occurs. Well, it only occurs once. So only one 58-year-old won the Academy Award. And N, we have what, 29 of these? So now if you want to find the percentile for 25, you do the same thing. So where's 25? 25 is right there. So 25 is the 4th data value. It only occurs once, and N is 29. So now you carry out the calculations. Oh, and I made a mistake. You know, it would be me making a mistake. So since it's the 19th data value, there are 18 values below it. Since it is the 4th data value, there are 3 below it. I apologize. I read it and then just wrote down the wrong thing. So when we carry out the arithmetic in that formula, we see that 58 is 63.8, and we round that up. So 58 is the 64th percentile. 25, we carry out the arithmetic, we get 12.07. So 25 is the 12th percentile. All right. Okay, again, here we go. Median, 50th percentile, or the 2nd quartile. And, you know, there's A percentile or a quartile may or may not correspond to a value judgment. You know, is the 90th percentile good or is it bad? Well, I guess it depends on if it's good or a bad. On a timed math test, the first quartile for time it took to finish the exam was 35 minutes. That might be bad because maybe you don't want it, you know, 3/4 of your students to take more than 35 minutes to take your exam. That might be a bad thing. And if it's really hard exam and you got a 2-hour time limit, then maybe 35 minutes is a good thing because you would expect students to take way longer than that. So my rule of thumb is, by the way, if you're interested, is that if it takes me more than 30 minutes to take an exam, then that's too long. If I personally take more than 30 minutes, it's probably too long for you. So I try to make exams for me, since I'm supposedly know the material, you know, I'm supposed to know all this stuff. If it takes me more than 30 minutes, then it's probably going to take you more than, that's for an hour, you know, maybe an hour for me if we're talking about a 2-hour exam. And your exams are 2 hours. Okay. At a community college, it was found that the 30th percentile of credit union units that students are enrolled in is 7 units. Interpret the 30th percentile. So that means 30% of the students are enrolled in 7 or fewer credit hours. That means 70% of your students are enrolled in more than 7 credit hours, and that might be a good thing. Maybe you're wanting more students to be more than just part-time. So that might be a good thing. If you're wanting all your students to be part-time, maybe that's a bad thing. I don't know. It just depends. All right, box plots. All right. So a box plot is a plot that uses your quartiles as a means of graphing. So it gives you a graphical image of the data point that breaks your data in half in the first and the third quartile. It also gives you the minimum and the maximum value. And the height of your box is kind of arbitrary. So what you have here is called, some call them box and whisker plots, because these are considered the whiskers. So a box and whisker plot starts at your minimum value. So you know whatever this data set is, and I don't know what it is, but the minimum value of this data set is the number 1. You draw a whisker, a straight line, and then you start the box. And this edge of your box is the first quartile. So 2 is my first quartile for whatever this data set is. So then we have a rectangular box. And in this rectangular box, we have a dashed line. And that dashed line is the median. The next edge of my rectangular box, or the upper edge of my rectangular box, 9, is my third quartile. Guess we could write this. And then my whisker extends on to my maximum value. So my maximum value is 11.5. And this is called the 5-point summary of your data. A box plot tells you 5 different values of your data. It tells you your minimum, tells you your first quartile, tells you your second quartile, your third quartile, and your maximum. So it's the 5-number summary of your data. Okay, so looking at this data again, here's the actual data for this box plot that we looked at just a second ago. You can see that the minimum value is 1. The first quartile is 2. The median is 7, if you were to calculate it. The third quartile is 9. And the maximum value is 11.5. So this box plot shows you the 5 summary data, 5 summary values of your data. All right. And I just discussed this. This is the 5-number summary. And you have several homework problems that ask you for the 5-number summary. And they want you to type them in order. So the first number in your 5-number summary is the minimum, which in this case would be 1. The first quartile would be the second number in your 5-number summary. That would be the 2. The median is your third number in your 5-number summary. That's 7. The third quartile is the fourth number in your 5-number summary. That's 9. And then the maximum is your 5th number in your 5-number summary. In this case, 11.5. All right. All right, so let's take this set of data and let's put this in our calculator. We're going to let our calculator actually calculate the quartiles and the minimum and maximum for us. And then we're going to draw a box plot. So if you want to do this, I'm going to let you do this now. If you want to take your calculator out and put this in your calculator, I encourage you to do that. It's good practice. Now, when I did this yesterday, when I was looking at this data, there are 40 data values here, but I noticed that many of the data values repeat. I have a 59, a 60, a 61, 62 repeats twice, 63 repeats twice, 64 3 times, 65, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 65 occurs 9 times, 66 twice, 67 twice, 68 twice, 69 once, etc. So what I thought, well, to save myself some typing, let me put this in my calculator in terms of a frequency table. So my data values are, as we said, so we have 59, 60, 61, 62, 63, 64, 65, 66, etc. And then, so this is my data value. And then over here, I'm going to put the frequency. So 59 occurs once, 60 once, 61 once, 62 twice, 63 twice, 64 3 times, 65, what did we count? 9, 66, is that twice, etc. And this saves me quite a bit of time when I put this in my calculator. So let's just go ahead and let me write it over here since I ran myself out of room. We got 67, 68, 69, 70, 71, 72, I'm still going to run out of room, 73, 74, 75, and 77. So 67 occurs what? Twice, 68 twice, 69 once, 70, 1, 2, 3, 4, 5, if I counted correctly, 71 twice, 72 twice, 73 once, 74 twice, and 75 and 77 once each. So I could, if I put this in my calculator in terms of a frequency table, it's just a lot faster for me to do than typing in 40 separate data values. So I'm going to put the data value in L1, and I'm going to put the frequency in L2. That'll just save me some time. So let me go over here. So that's what I have in my calculator. So in L1, I have the actual data values: 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. 70, 71, 72, 73, 74, 75, and 77. And then in L2, I put the frequency. So 59 occurred once, 60 once, 61 once, 62 was twice, 63 was twice, 64 was 3 times, 65 was 9 times. Is that correct? Yep. 66 was twice, 67 was twice, 68 was twice, 69, the frequency was 1, 70, the frequency was 5, 71, the frequency was 2, 72, the frequency was 2, and 73, 1, 74, 2, 75, 1, and 77, 1. So now that I have my data in list, now let me repeat. You could have typed all 40 values in your first list. You did not have to do this in a frequency table. I did it because I'm lazy and I didn't want to type in 40 numbers. But then you could say, you could argue, yeah, but then you typed in more because you typed in 2 lists, which is probably true. But that's what I did. So I typed the data value in L1 and the frequency that that data value occurs in L2. Now, the other advantage to doing this is it helps you if I wanted to draw a histogram. All right, so now that I have my data in my calculator, I'm going to exit out of my list. So I'm going to do second quit. Now, just to remind you, to get your list, you go Stat, Edit, and that gives you your lists. All right, so I'm going to get out of here, do a second quit. Now I want to let my calculator calculate the quartiles for me, and the median, and the minimum, and the maximum. I'm going to let my calculator do that for me. So I'm going to go back to my stat menu. And I'm going to arrow over one menu to the calculate menu. And number 1 is my one variable statistics. That is the function that's going to calculate these things for me. So I'm going to hit enter, and it's going to ask me for various things. Now, if I typed all 40 of those data values in the first list, the list would be L1, and the frequency would be empty. There would be nothing in the frequency. But I typed the list in L1 and put the frequency in L2. So I'm just going to tell my calculator that. So I'm going to say the list is second L1. So that's where my data values are. I'm going to hit enter. And my frequency I put in L2. Again, if I just typed all 40 values in L1, the list would be L1 and the frequency would be empty. You'd delete whatever was there. Now I'm going to hit enter again, and I'm going to hit calculate. All right, so this screen is the summary of my one variable statistics. And we'll talk about the data values X bar and S sub X later. Right now, let's just concentrate on the values of N equals 40 and below. So N equals 40 tells you the number of data values you had. We had 40 data values. So that concurs with what we thought we had. You can see right there, Q1 is 64 and a half. So my first quartile is 64 and a half. I'm going to arrow down. The median, or the second quartile, is 66. Oh, I just ignored the minimum value. The minimum data value was 59. We knew that by looking at our data, that the minimum was 59. Arrow down again. The third quartile is 70. And the maximum value, is 77. So we can find now our 5 summary data values, or excuse me, our 5 summary values, not data values, 5 summary values. The minimum's 59, the first quartile 64 and a half, the median 66, the third quartile 70, and the maximum is 77. Now I can graph this as a box plot. So what I'm going to do is I'm going to go to my stat plots. And remember, to find my stat plots, I go second y equals. In blue, above the y equals is your stat plot. So I'm going to do second y equals. And I still have plot 1 on because I graphed this the other day. So I'm going to graph my box plot in number 1, since that's what's on. So I'm going to hit enter. Make sure that it's on. And then for the type of graph, I'm going to arrow over to the box plot. I'm going to hit enter. Make sure that the box plot is turned on. Now, since I put my data values in L1 and my frequency in L2, I'm going to tell my calculator that if you just put your data in a single list, you didn't make a frequency table, the X list would be L1 and the frequency would be empty. There would be nothing there. Okay. So I got my X list is L1, my frequency is L2. So now I'm ready to graph this. So to graph this, I'm going to go to Zoom, which is at the upper part below my display. Zoom 9, Zoom stat. My calculator will adjust the screen to fit my data. So I'm going to go Zoom. Number 9 is Zoom stat. And there's my box plot. And if I turn on my trace, you can see that when you hit the trace button, the cursor blinks on your median. You can use your arrows to go to the first quartile, and it tells you down at the bottom what your first quartile is. You can see what the minimum is. So you could actually graph your box plot without ever calculating your statistics to see what your quartiles and your minimum and your maximum is. You can graph the box plot of your data and then use the trace feature to find that 5-point summary. So if we go back to the right, my third quartile is 70 and my maximum is 77. Now you have in this section of homework a box plot that you have to draw. And oh my goodness gracious, this thing's hard to draw. It's really hard to draw. So, and I can't remember what question number it is. I should probably put that in my notes. When you get to that problem where you have to draw the box plot, if you can successfully draw it, I will give you extra credit. Otherwise, I will give you credit for that problem, nevertheless, for that part of the problem, because the rest of the problem is good. You know, I ask you to find the quartiles and all that kind of stuff. That's good. That's something you should be able to do. But drawing that in my open math is extremely difficult. I finally did it correct the other day. I've tried it like 24 times and I finally got it correct. I was so careful and got it correct. But again, when you get to that problem, that part of that problem in my open math, give it a try. If you get it right, I will go in there and award you extra credit for it. If you don't, I'll give you credit anyway. You're not going to get that part incorrect. I promise. I'll give you credit for it. All right. Let's go back to PowerPoint and see where we're at, because we're about out of time. All right, that is a good place for us to quit. We'll pick this up on Thursday. Actually, yeah, let's go ahead and finish. We only got 2 slides. The fact of the matter is, some box plots, I mean, depending on your data, you could have the minimum and the first quartile being the same point, or you could have any of these data values being the same point. So that can affect your box plot. So in this case, the first quartile and the minimum, and maybe the median, I don't know, are all the same value. And the third quartile, maybe the median's 5. I don't know. I'd have to see the data to know for sure. But I do know the minimum in the first quartile is 1 and the maximum 7. You can also tell if your data is skewed or not from your box plot. So you can see in this first graph, the median is kind of, or the second quartile is kind of far to the right. That means you're skewed to the left. In the second, the median smack dab in the middle. That means your data is symmetric. And in the second one, you can see that median or that second quartile is kind of pushed to the left. That means your data is skewed to the right. So if your median is pushed to the right, you're left skewed. If your median is pushed to the right, you're left, to the left, you're right skewed. All right. And that is the end of that. So we'll start section 2.5 on Thursday. Are there any questions? All right, we will see you Thursday if there are no questions. Talk to you then. Have a good rest of your day.
Thank you.
Thank you.
Yes, ma'am. How are you feeling?
I'm okay.